Okay, for the continuation ng ating discussion, ng ating lesson, bakit ito yung equation natin sa level of AA? Now, if I'm going to determine the resultant of our load diagram up to the cutting section of AA, ibig sabihin, ito lang yung consider kong portion muna, no? Yung bibilugan ko para makita ninyo. Ito lang. Yung may distance na x. Hindi kasama yung portion na nandirito. But as we all know, na yung load niyan is y. Nung buo pa yan, 1,000 ang load natin, 1,000 Newton per meter. But by this time, it is a variable of y. Okay? If the load is y and the distance is x, ano ba ang area ng triangle para malaman natin yung ating r? So let us compute for the area for our resultant so that we can calculate. This is equal to 1/2 of x times y. So definitely our shear is 1/2 xy, but we will use a sign of negative because the direction of the force is downward. That's why we have the shear is equals to negative 1/2 xy. But as I mentioned kanina, nakalculate natin ang value ng y, and here is it. Substituting it here, then we can have this equation as a value for our shear, or B. So continuation, we can have now B is equals to negative 250 all over 3x squared. Then to be followed by this. After calculating for the shear, we can now calculate for the moment. Bakit x over 3? Okay? Bakit x over 3? Ito yung cutting natin. Ito yung cutting section natin, ano? Okay, let me explain it to you. Since this is our cutting section, yan. So ito yung point natin, dito tayong magmo-moment. It so happen that this is downward, and ang value is 1/2 xy. Definitely, we will use the sign of negative since it is counterclockwise. Assuming na clockwise moment is positive, kaso kapag renotate natin yan, ang direction will be counterclockwise. That is why we have used a negative sign. Ang lever arm, kapag ganyan yung figure, from here up to the eye is 2/3 of the dimension, 2/3 of x. From here naman hanggang doon is x over 3. Kaya lang dito tayo nagmo-moment. So ang layo ng ating r, ng ating 1/2 xy is only x over 3. That's why we have x over 3. And then to simplify for our moment equation, we have it as, yan, simplify pa natin. Kasi nga may value tayo ng y, di ba? So sinubstitute ko yung y. The value for y is 500x over 3. And here is it. Ito yun. Yung y dito, substitute, but x times x is x squared. That's why we have negative 1 over 6 of x squared times 500x over 3. Continuation, simplify pa natin. Yan ang value ng ating moment. Question so far? Wala bang talong? Wala? Wala bang namumong tanong? Klaro pa ba ang computation natin? Kung bakit nag-arrive, okay, sa negative 250 over 9x cubed. Kasi nga, 500 over 18 are both divisible by 2. That's why we have 250 over 9. Reducing the fraction to lowest term. Thus, the maximum moment is 250 over 9, but the total dimension or distance of the span of the beam is 6 meters. Substituting it, we can have now our maximum moment, 6,000 Newton meters. Okay? So, nakalculate natin ang ating maximum moment. And yet, hindi pa tapos ang ating problem. We have to calculate now for the maximum flexural stress. As I mentioned kanina, ang formula ng flexural stress is MC over I. Nahanap ang maximum moment. Ano ba ang I natin? Ano ba ang C natin? Tapos na kayo ng centroid topic, di ba? Sa statics of rigid body. So, madali na lang sa inyo yung mga yan. What do you think will be the value of C here? Any idea? Ano ba ang value ng ating C? Is from our given figure and problem. What do you think will be the value of C? Alam na natin ang maximum moment eh. Ano kaya ang value ng C? Ano ang value ng I? Just take a look with the cross-section of our figure. Isn't it that it is a rectangular? BD cube over 12 ba? BD cube over 36 ba yan? Ano ba yung I niyan? Okay, let me show it to you. Kailangan i-recall ninyo yung mga napag-aralan ninyo before. Kailangan ninyo yun. Kumbaga, domino effect yan. May domino effect ang pag-aaral ninyo. May domino effect system kayong mararamdaman. Okay, let me explain it to you. 600 times 0.100. Hindi ba ito yung neutral axis natin? So definitely, ang centroid natin, ang C natin is 100 millimeters o 0.1. Converting it into meters kasi nga ang maximum moment natin, ang unit is Newton meter. So kailangan nasa meter din ang ating centroidal value, 0.100 meter. Okay? That is also equivalent to 100 mm. The rectangular yan, ang ating I will be BD cube over 12. Hindi ba natatandaan na kapag rectangular, ang formula ng I, balikan ninyo yung napag-aralan nyo, will be BD cube over 12. Yan, BD cube over 12. Kailangan ninyo yan. So the depth is 0.2 and the base is 0.06. So substitution process, we can have this now. And then for maximum flexural stress at the wall is 15 times 10 to the 6 Newton per square meter. Yan. Okay? Ito ngayon yung 40 from the top and then hanggang doon, then 60 yung dito. Kakailangan nyo mamaya yan. Kung babalikan kasi natin yung problem, kung babasahin ko ulit, ito kasi yung nabanggit kanina eh. Kailangan tindihin yung maigi yung problem. Determine the type and magnitude of the stress in the fiber 40 mm from the top of the beam at a section 3 meter from free end. Kaya, ipinakita ko na kaagad yung 40 sa top. Okay? Yun yung reason. And for the continuation, at the span of x is equal to 3 meters sa ating 6 meter na beam, kasi nga 3 meters lang dimension eh, yung requirement. M is equals to negative 250 over 9, then 3 cube. Substitute lang tayo doon sa equation na nabuo natin para malaman natin ang moment at x is equal to 3 meters. So we can have it as negative 750 Newton meter. Naintindihan ba hanggang dyan? Naintindihan ba hanggang dyan yung problem? Class? Klaro ba?
Yes po, sir.
Okay. Thus, the stress My over I is equals to 750. Okay. Bakit 0.06? Kasi nga yung 40 eh. Na-deduct na natin, di ba? Yung 40 mm which is equal to 0.04. Na dati ang C natin dito is 0.1. Kaya lang requirement from the top, 40 mm. Dineduct natin sa 0.1. Kaya naging 0.06 na lang. But that does not mean that we're going to calculate the inertia na hindi kasama yung 0.4 sa taas, yung 0.04, no? Yung I natin is same pa rin. Hindi mababago yung dimension ng ating or cross-section ng ating beam, BD cube over 12. 0.06 pa rin ang base, ang depth is 0.20, Dahil nga 60 by 200 yan, rectangular. Kaya BD cube over 12. Therefore, our stress is 1,125,000 Newton per square meter or 1.13 megapascal. Kung i-round up natin yung 1.125 is 1.13 megapascal. Okay? Can you follow? Kasi nga, ang megapascal, kapag Newton per square meter yan, 1 times 10 to the 6 yan. Automatic. Okay, wait lang no, naka-post ko lang sandali. So, ang value ng ating flexural stress is 1.13 megapascal. And for the continuation, ito yung ating conclusion. The negative moment of this section creates tensile stress on top of the neutral axis and compressive stress below. And that's it for our problem number 1. Questions so far? Wala ba kayong gustong itanong? Okay, since walang kumikibo, automatic, walang gustong magtanong. Okay, we have another C board exam problem. And this example was already given in a licensure examination. Hindi lang in-state kung ano yung exact date. Okay, and this is our problem. A 40 millimeter diameter beam. Okay, yung spelling, no, nagmamadali si sir mag-type, is used as a simply supported beam 2 meter long. Okay, determine the largest uniformly distributed load which can be applied over the right up of the beam if the flexural stress is limited to 60 meganewton per square meter. This is also megapascal, 60 megapascal. Okay? Okay, let's proceed. For the solution, yan ang ating figure. So, circular yung ating dimension. Okay? Circular siya. Okay, nakikita ba yung dimension? Naintindihan ba? Nakikita ba yung sample ng ating beam? So, may dalawang reaction na R1 and R2. Hindi siya cantilever ngayon. Simply supported siya. Kaya lang may portion na uniformly distributed na may load na W, Newton per meter. And then, nandiyan naman, 2 meters lang yung total span ng ating beam in this case. Now, how do we solve the problem? So first, we have to take summation moment at point C, clockwise moment positive. So dito tayo magmo-moment so that we can solve for the reactions. Okay? Bakit 1 up yun? Okay. If this is RR, definitely sa gitna yan, no? This is RR. Definitely, this is weight times 1. Okay? Kaya lang ang layo, sigurado niyan, kung 1 meter yan, is 1 up or 0.5. That's why we have this. And since the resultant force is downward and its direction to point C is counterclockwise, we have used negative. R1 to be multiplied by 2 because ang layo ng R1 sa point C is 2 meters at ang rotation direction niya is clockwise. And then we can also calculate now for R sub 1. We have W over 4 newtons. Ang unit natin is Newton. And then since we already have R1 value, pwede na natin ngayong i-calculate ang ating R sub 2 by using the summation of forces vertical. So solve na natin ngayon ang R2. Ang value ng ating R2 is in this equation. 3W over 4 Newton or 3/4 of weight of the uniformly distributed load natin sa taas. And ang unit is Newton. So we already have now R1 and R2. Anyway, ano ba yung requirement? Basahin nga natin. Determine the largest uniformly distributed load which can be applied over the right half of the beam if the flexural stress is limited to 60 meganewton per square meter. So pinapakanap ang W lang. Since we already have our reactions R1 and R2 in terms of W, considering the left of section BB or segment BC, okay, considering this, eto, pakita ko ulit. Yan muna, considering left of section AA muna. Nag-skip tayo. Ito muna, yung portion na to muna. This portion first. We already have our R1 and a receipt. And we have assumed that the distance of reaction 1 to this cutting portion or section is X. Distance X. So what do we do then? Let us solve for BAB. Kasi nga hanggang B yan eh. A and then B. So we calculate for shear AB. R1 is W over 4. Definitely. Shear pa lang naman tayo eh. So nakalculate natin ang ating BAB. Therefore, BAB is really equal to R1. Kasi dadalawa lang naman ang mga forces natin eh. Kung magsa-summation forces vertical tayo, dalawa lang, ang BAB lang at ang R1. That's why BAB is assumed to be also R1, which is equal to W over 4 Newton. After ng cross-section na yan, i-consider naman natin from point A hanggang dito sa cutting section BB natin sa left. Okay, by the way, this is the moment. R1 multiply by 1. Okay, we have W over 4 Newton per meter. Kasi nga, 1 meter lang yan eh. Di naman 2 meters ang kukonsider natin na sa UL. Let us correct that. This is only 1 meter. Take note of that. 1 meter lang yon. Okay, let's proceed. Considering left of section BB, segment BC. Yan. So dito naman tayo ngayon. Left of BB. Ito yung left ng BB, yung buong yan. So again, let us compute BBC. Okay, W over 4. And then also W times X minus 1. Bakit X minus 1? Okay, let me show it to you. If this is RR, definitely this will be W times what? Times ano? Kasi nga, ito yan eh. Di ba 1 meter lang yan? Okay, so this is X minus 1. Can you follow? So kailangan nating i-deduct yung 1. Kasi nga 1 meter lang ito eh. Okay, can you follow class? X minus 1. So from here, okay, this is X. Alisin ko muna. Nagpurin ko muna para klaro. W yan, di ba? So kung 1 yan, ito yung X, ito yung pinag-uusapan natin, X minus 1, para mas klaro. Mamaya na yung moment. Okay, dito naman yung moment natin. Yan, okay. So X yan, no? Pakita ko ngayon yung R. Para hindi nakakalito. So W times X minus 1. Kasi nga, this is X minus 1. Can you follow class? If this is X, and we're going to deduct that, that will be X minus 1. Nakakasunod ba kayo? And then ito, 1 half of X minus 1. Kasi nga, X minus 1 yung buong yun eh. Ulitin ko lang, no? Parang may typo ako. X minus 1 over 2 ito. Yan. Ito naman ang x minus 1. Para klaro. Okay? Klaro na ba dyan? Ulitin ko, no? Para klaro. Para mas malinaw. Ang hirap kasi magsulat kapag online. Okay, ulitin ko, no? This is x, that is 1. So definitely, this is x minus 1. Yung buong yan, ito yung x. Ito naman, hanggang doon is 1. That's why this is x minus 1. Now, if this is RR, this will be equal to W times x minus 1. At dahil dyan, siyempre ito, ang lever arm na yan is magiging x minus 1 over 2. That's why we have now this equation. And for the continuation, MBC is maximum when BBC is 0 daw. If BBC is equals to 0, equating it to 0, we can have then the value for W. Bakit naging 1/4 is equal to x minus 1? Okay, let me explain it to you. If I'm going to equate this to 0, kung i-equate ko yan, magiging 0 yan, yung BBC, ito yung arrival. No? But if I will transpose this to the right, magiging positive ang sign. Magiging ganito yan. Equal and x minus 1. Definitely, we can cancel both W. Matitira na lang dito, 1/4. That's why we have it as 1/4 is equal to x minus 1. 1/4 is equal to x minus 1. And with this, pwede na natin i-calculate ang value ng ating x. And what is then the value of our x? 1 1/4 meter or 1.25 meters? Since alam na natin ang ating x, pwede na natin i-compute ang ating maximum moment. Pwede na ba? In terms of W, 0.28125 W ang ating nakuwang result sa ating maximum moment. Makakatulong ang maximum moment sa paghahanap ng weight ng ating W na inaanap. So para mahanap ang W, the next thing to do is to consider the flexural stress. Then ngayon papasok ang ating flexural stress. And that is equal to M over section modulus or MC over I, another formula for flexural stress. For circular section, okay, pi d cube over 32. Kapag rectangular, b d cube over 12. By this time, circular ang section natin, ang S value natin sa circular section, always remember na pi d cube over 32. Yung I naman sa rectangular is b d cube over 12. Pero dito S ang kinonsider natin sa circular section, pi d cube over 32. And I'm hoping na alam na ninyo ang mga yan kasi natapos na kayo sa topic na yan. Since M is equals to flexural stress times section modulus, ang M natin kanina na naanap, gagamitin na natin. Yan, yung 0.28125W. Okay, direct substitution tayo. Okay, M is 60 times 10 to the 6 Newton per square meter. Pi over 32.040 cubic. Magiging cubic meter yan, no? Then cancel dito. Square meter. Meter na lang matitira sa taas. Kaso, nakalculate natin ang ating W. Okay, I repeat. May value tayo ng flexural stress given niya sa problem kanina ng section modulus. So, saan ang galing yung 0.04? Ito kasi yung diameter ng ating circular section. Yung diameter niya is 0.04 meter. E so, happen lang ang formula ng ating S is pi d cube over 32. So, direct substitution lang tayo. So, ito, Ito siya. Wherein actually ito din yun. But so happen that this is already a given from our problem. Babalikan ko yung kanina. Ito yung problem eh. Para mas klaro, no? Ibinigay yan kanina. Ito yun. Given na yan. Okay? Para klaro, no? Yan, dito tayo ngayon. So what is the value for M? Yung maximum moment natin kanina, here is it actually. Ito yung M value natin. Na na-compute kanina yung maximum moment in terms of W. Simplifying yung nasa right-hand side ng equation, makakuha tayo ng 377. Full number na kuha natin. Exactly siya, no? And then we can now solve for W. 1,340 Newton per meter. Yan ang ating inaanap kanina. Economic sections, selection criteria, S equals to M over equal or greater than M over flexural stress. Okay, let us see. A beam must be selected whose section modulus is equal to or greater than the ratio of bending moment to allowable stress. Dagdag kalaman lang yan. So atin ang nakalkula ang W na ating hinahanap. Question so far? Wala ba kayong tanong sa problem number 2? Class? Question so far? Wala ba kayong tanong? Hello? Oliver, Duay, yung mga participant dito, Aileen, Halan, Carl Lewis, wala ba kayong gustong itanong? Malinaw pa ba ang discussion natin? Are you still with me? No one is responding? Class?
Wala naman po, sir.
Okay. So let's proceed. For the third C board exam problem. A 10-meter beam simply supported at the ends carries a uniformly distributed load of 16 kN per meter over its central length. So napakasimple lang pala ng problem na to. Simply supported lang and then uniformly distributed. So rectangular ang ating load diagram. What is the greatest W-shaped beam? Kailangan na natin ng W-shaped beam. So ibig sabihin, still yung beam natin. Hindi sa made of concrete and hindi rin made of timber. That will not exceed a flexural stress of 120 megapascal. Dapat lang hindi mag-exceed doon sa allowable na 120 megapascal. So pinapaanap ang actual stress ng beam natin. Kung hindi yan mag-exceed sa 120, ano naman ang ating actual stress in the beam? At ano yung dimension ng ating W-shaped beam? Anong quality niyan? Anong property niyan? So, anong W-shape beam yan? Actually, sa estimate, kapag ang mga beam mo W-shape, actually, kapag nag-estimate ka, hindi yan by piece, no? By kilogram pa rin. Parang yung mga 10 mm, 16 mm, and then 12 mm diameter of bore na ginagamit nyo sa kasalukuyan, ganyan din ang kalkulasyon sa mga I-beam, sa mga W-shape beam, o kung anong klase mang beam yan, by kilogram pa rin. Dagdag kaalaman lang. So ito ngayon yung figure natin ng ating shear and moment diagram. Ginuwit ko na kaagad. Para sa ating 10-meter beam na uniformly distributed na may W load na 16 kN per meter. So given na dyan yung kanyang mga reaction, R1 and R2, parehong 80 kN dahil symmetrical naman. At yan ngayon ang ating shear diagram. Meron tayong maximum shear na 80 kN and then this is our moment diagram as shown below. And let's continue. So madali na lang solve ang maximum moment dyan, no? So our maximum moment will be 1/2 of 80 times 5. And considering this area, yan, yung nakashade na yan, 5 times 80 divided by 2, we have a 200 kilonewton meter. So ito yung 200 natin, yung maximum moment natin. So we already have the maximum shear and the maximum moment. Now, ano yung partisipasyon ng figure na yan, ng computation na yan, sa ating mga inaanap sa problem? First, we need to compute for the flexural stress is equal to M over S. And S equals to M over flexural stress. Let us now calculate for the S. Bakit kailangan calculate ang S? Yan ang gagamitin natin sa table sa paghanap ng correct W-shaped beam. Yung makukuha mong S dito, value na 1.67 times 10 to the negative 3. Okay, saan ang galing yung M na yan? Actually, nakalculate, ito yung 200 kilonewton meter eh. Okay? Ito yun. Multiply lang natin ng 1,000. Ito yung M. And then, saan ang galing ito? Given na yan. Ito, no? 120 megapascal. So that is also 120 times 10 to the negative 10 to the 6 Newton per square meter. Okay, since we have already calculated for the S value, the modulus section or section modulus, S equals to 1.67 times 10 to the 6 cubic millimeter. So we need to convert this into cubic millimeter. Kasi sa table, yan. Tingnan sa palagay ninyo, balikan ko yung kanina, tandaan ninyo 1.67 times 10 to the 6. Kung yan yung table, sa palagay ninyo, nasaan yung gagamitin natin? Try nyo nga maghanap. Excuse lang, 30 seconds lang habang inaanap yun. Hanapin nyo muna, tapos sabihin nyo sa akin kung ano. Kukunin lang ako sandali. Okay, so let's proceed.